Hello everyone and welcome to iLAN Technologies presentation on Draitec Wireless Mesh Solutions. This will be the first of a two-part webinar series. In this webinar, I'll introduce you to the wireless mesh solutions available in the latest Draitec wireless routers and access points. In part two, I'll go through management and troubleshooting of wireless mesh installations. My name's Darren and I'm the Queensland sales rep at Draitec Australia and New Zealand. I'll start with an introduction to wireless mesh networking, what it is and how it works, as well as which devices support Wi-Fi meshing. Then we'll go through the steps to set up a wireless mesh network, and we'll finish up by looking at some additional features. If you have any questions during the video, please comment in the chat box on the right side of the screen and stick around at the end for a 5-minute Q&A. If you're watching this after the premiere, please comment below or send an email to sales@draitec.com.au. Okay, wireless mesh networking. So what is a wireless mesh network? Wireless meshing is the fastest way to extend the Wi-Fi coverage throughout a building or location. It's particularly handy to extend Wi-Fi to areas where it's not possible to run Ethernet cabling. So instead of using Ethernet cable uplinks to interconnect all the access points and wireless routers, the devices are interconnected using Wi-Fi. Although it is still possible to also use cable connections in some circumstances, which I'll cover later. As shown in this diagram, we have 3 access points interconnected to create a single wireless network within the building. This allows for seamless roaming for users as they move around. There is a limit to the number of devices in a mesh network, as well as the number of hops between access points linked together. I'll go into more detail about this shortly. So why would you use a wireless mesh network? The first bonus is easy installation. No Ethernet cabling is required to be installed, which saves time as well as the cost of the installation. Configuration is also dead easy. You don't need to configure each access point individually because the devices are all automatically configured during the mesh installation from the mesh root device. Dead zones are easily omitted by placing the access points where they are required without the limitation of needing an Ethernet cable to connect them to the network. The second reason to set up a mesh environment is resiliency. The interconnection between nodes provides the ability to self-heal if a mesh node fails. In that event, connections are rerouted to bypass the failed device. Next is the ability to have synced settings. The mesh group shares the same wireless LAN configuration and automatically builds a roaming environment. And finally, we have central management. Grouping the access points allows the network administrator to monitor all the clients and devices from a single management platform. Great, so how does it work? So instead of having a wireless controller to manage multiple APs, in a wireless mesh network we have a mesh root device, which is like the boss who manages the wireless mesh network, and the attached mesh nodes, which are like the drones and workers. Up to 7 mesh nodes can be added to a Draitec mesh network. The mesh root will synchronize the configuration of all the mesh nodes to create a single Wi-Fi network and make it appear as a single access point. Okay, so what happens if a single mesh node fails or goes offline for some reason? In that event, the mesh root will create a new path to other access points to maintain wireless connectivity. This is known as self-healing. So in our diagram here, we have a wireless mesh running smoothly, but suddenly one of our APs goes offline, which also takes out the AP connected to that one. Now, another AP within range picks up the slack and creates a new hop to it, bringing that one back into service. Another point to note when we talk about hops is that there is a maximum of 3 hops from the mesh root to the furthest access point. That is, the wireless data can only traverse 2 other access points before it reaches the furthest access point. Wireless mesh is featured on most dual-band 802.11ac routers and access points in the 5 GHz band. Draitec access points currently supporting it include the VIGA AP802. Just bear in mind this one can only be used as a mesh node, not a mesh root. Other access points can be used as either mesh roots or mesh nodes. These include the VIGA AP903, which can sit on any flat surface, or it can be wall mounted. The ceiling mountable models are the VIGA AP912C, the VIGA AP960C, and the VIGA AP1000C. These can also be wall mounted. Outdoor access points include the VIGA AP918R and the older VIGA AP920R. These are ruggedized to take a beating from the weather. Here's the router models which support the wireless mesh feature. These can only be set up as mesh roots, not mesh nodes. Broadband routers are the VIGA 2926 and 2927, AC, VAC and LAC models. DSL routers include the Vigor 2862, 2865 and 66 AC, VAC and LAC models. The .11ax or Wi-Fi 6 routers and APs currently do not support Wi-Fi meshing. Okay, let's take a closer look at the roles of the devices in a mesh network. The mesh root device needs to be attached via Ethernet cable to the LAN and is hop 0 in the mesh network. It scans for wireless node devices and will set up connections between access points and itself. Once set up, the nodes can be moved around and the hops will be created. Both the mesh root and the nodes can provide connectivity to wireless devices. A mesh group must include one mesh root, but it can have up to 7 mesh nodes. There are a number of functions the mesh root device performs. These are: number 1, trigger mesh members to discover new mesh nodes; 2, adopt or delete mesh nodes; 3, push configuration to mesh nodes; 4, trigger mesh nodes to detect signal strength with other members and make decisions of mesh members uplink; 5, monitor mesh members, mesh links and Wi-Fi clients; 6, backup, restore mesh group; 7, reset the mesh group; and finally, number 8, run iPerf server for mesh speed test. This is used to check there are no communication and speed issues in the wireless mesh network. Mesh nodes are access points that form part of the wireless mesh network. They can be connected using Wi-Fi or they can be connected using LAN cabling, which is called a wired connection. There are several functions handled by mesh nodes. These are: respond to mesh members discovery, detect signal strength with other members, and respond to mesh root. Establish uplink according to mesh root's decision, monitor Wi-Fi clients, and run iPerf client for the mesh speed test. Let's now look at the steps to set up a wireless mesh network. There's 3 steps to creating a mesh group. The first step is to configure the mesh root. Next, we place the mesh nodes close to the mesh root, then scan and add members into the mesh group. The mesh root then pushes the configuration to the mesh nodes. Once this is done, move the mesh nodes to their designated positions. Finally, power on mesh nodes hop by hop, making sure they're showing as online in their status pages. It's recommended to first power up the mesh nodes closest to the mesh root so these uplinks can be selected first, then power up the mesh nodes that are further away. This will avoid the mesh root from selecting the weaker link as the primary uplink to other mesh nodes. Once all the mesh connections are re-established, click on Auto Reselect to force the mesh root to optimize the uplink. So that's the basics. Let's now look at the methods. There are 3 methods that can be used to deploy a wireless mesh. These are the Dratec Wireless App, a Quick Start Wizard, and manual configuration. The table shown here indicates what settings can be used using each of these methods. Using the Wireless App and Quick Start Wizard allows you to quickly set up a mesh network with minimal settings compared to manual configuration where you can control all settings used. I won't go into too much detail about how to use the Dratec Wireless App to configure a mesh in this webinar, but if you'd like more detail about it, I'll include a link below to a video which goes through the steps. I'll also include links to where you can download the app. To configure the mesh root using the web interface of Dratec devices, in a supported router, go to the Mesh Setup menu and select Enable Mesh as shown here. With Dratec Vigor access points, we have 2 ways we can set them up as mesh roots. Those are the Quick Start Wizard or by selecting Mesh Root Mode in the Operation Mode configuration menu. I'll go into each of these shortly, but first I'll explain a couple of technical details about the process and how mesh devices communicate. Mesh nodes can be connected either by a wireless or a wired uplink, which is if they're connected to the network with cables. Wired uplink might need to be used when the access points are connected to a switch, for example a power over Ethernet switch, which is a common way for APs on a network to be powered. Also, wired uplink has better performance compared to wireless uplinks. You should note that modifying the uplink setting will disconnect the mesh node for a moment as it reconnects to the mesh group. Another point to note that is if the wired uplink fails for some reason, then you'll need to manually change the setting to wireless uplink mode. With the current firmware, it doesn't switch automatically. To make first-time deployment of access points easier, they come with pre-configured settings to allow them to automatically select if they'll be running in AP mode or mesh mode, as shown in the flow diagram here. The first thing it checks is if it's in factory default status. If it is, then next it will check if it has an Ethernet uplink. From there, depending on the connection state, it will either become a mesh node using Wi-Fi or AP mode, mesh route using the Ethernet connection. This also depends on whether the access point can obtain an IP address via DHCP. If DHCP is not available, it becomes a mesh node. For access points not in the default state, if you don't want to reset them, you can log into their web user interfaces or use the Draitec Wireless app to manually configure them as mesh nodes. Let's look at how we work out the number of hops in a mesh network. As mentioned earlier, there's a maximum of 3 hops allowed in the mesh network. The mesh root device is counted as hop 0, as are mesh nodes connected by LAN cables. Then for a wirelessly connected mesh node, its hop number is the uplink hop plus 1. As shown in this diagram, the solid lines are Ethernet LAN connections with attached devices not adding to the hop count. The mesh root device can see the hop count for all mesh members, as shown in the screenshot of the mesh status page at the bottom right here. However, the mesh node can only see its own hop count. I'll briefly go through the mesh communication mechanism for those interested in the more technical aspects of what's going on. VigaMesh uses UDP port 4946 to discover mesh devices, then to build the connections between mesh devices, WDS, that's Wireless Distribution System, is used. Mesh root and mesh nodes build connections with WDS. Here the mesh root and mesh node configure each other's MAC addresses automatically. The connection is secured with ECDH key exchange and is encrypted with 168-bit PSK generated by the group key. In addition, TR069 is used in the control plane of the VigaMesh. This is used to configure mesh nodes and retrieve status information from them. The information is periodically updated every minute. However, this does not affect management of the devices using Viga ACS3 or Viga Connect. Okay, back to the quick start wizard to set up the wireless mesh in a Viga AP. The first step is to set up the mesh root. To do this, select mesh root in the operation mode configuration menu as shown here. Incidentally, if you prefer a written guide to follow, complete instructions for setting up a mesh network with the Quick Start Wizard are available in Knowledge Base Article 5682 shown here. I'll leave a link to that in the description below. Next steps are to enter the first and second SSID and security details for all wireless bands, then enter the connection reconnection times for the second SSID on all wireless bands. The third step is to change the admin password for all member access points. For more sophisticated configurations, you can go through each function page if you like. The final step is to click on Finish to save the settings. Once the mesh root is set up, it can scan for available mesh nodes by broadcasting a discover message with 2 possible scenarios, which are creating a new mesh group or expanding an existing mesh group. During the discovery process, Wi-Fi clients are not allowed to connect to the access point during the 10-second scanning period. After receiving the discover message, available mesh nodes will respond with a register message to join the mesh group. Note that for this process, access points must be at factory default settings to allow auto discovery and configuration. As I mentioned earlier, to start the discovery process, it's recommended to place the access points to be searched near the mesh root to make it easier for the initial setup. Then they can be moved to the required locations afterwards. Then go to Mesh Setup menu and click on the Search button. Discovered devices will appear in the search list. To add these devices to the mesh group, just select them and enter a name for each of them in the device name field. Then click Apply. The devices will then be moved to the mesh group table. If you want to add an additional mesh node, click on the search button again in the mesh root. That will trigger mesh node discovery in existing mesh nodes to find the available mesh node and add it to the group. After the mesh nodes join the mesh group, the mesh root will push settings to all members. If you use the Quick Start Wizard, the settings that will be pushed to all mesh nodes are the access point admin password and the SSID security mode and passwords for each wireless band. In addition, bandwidth limit and station control can be enabled for the second Wi-Fi in the mesh nodes. Using the Draitec Wireless app to set up the mesh will be similar to the Quick Start Wizard on the mesh root, and it will push the same parameters to the mesh nodes. Additional parameters can be configured in the Mesh Basic Configuration Sync menu. This allows the mesh root to specify more parameters that can be pushed to mesh nodes. This includes management on member APs, including the AP admin password and syslog mail alert, 2.4 and 5 GHz WLAN settings with the same SSID security mode and password, VLAN member LAN isolation of each SSID, roaming rules, which includes fast roaming, AP assisted roaming, fast transition roaming, and band steering rules. Also, policies on Wi-Fi clients, including the allow block list, connection reconnection time for each SSID, and device object device group schedule for applying policies. The final step when setting up a Wi-Fi mesh network is to verify the deployment. This can be done by checking the mesh network section in the dashboard of the mesh root device. It shows the root WUI mesh topology, member online status, signal strength, and uplink downlink of each mesh member. The color of the signal icon indicates the strength of the wireless signal at each access point. In the Dratec Wireless app, we can see the same information that is available on the web page of the mesh root device. I'll finish up today by showing you some additional features that are available when setting up a Wi-Fi mesh network. The first one is Mesh Wired Uplink, which I touched on earlier. This is a Wi-Fi mesh feature which supports access points connected to the mesh root by cables. When using a Wi-Fi router or access point as a mesh root, mesh nodes can be connected via either cable or Wi-Fi. One situation where you might want to use Mesh Wired Uplink is when your VIGA APs are powered by PoE from a PoE switch and you want a mesh network. However, because they're attached by cables which provide both power and data to the APs, a loop between the wireless and wired connections for each AP occurs. Enabling the wired uplink option will prevent this loop. You'll find that option in the Node AP in the Mesh Setup menu, as I have highlighted here. The wired uplink checkbox will appear when Mesh Node is selected. More details are available in Knowledge Base Article 7446 if you'd like to learn more about using this feature. That'll be in the description below, so you can click on it instead of trying to type it out manually. Wireless mesh nodes automatically select the next hop in the mesh to connect to the mesh root. However, the next hop may not always be the best node for it to use to achieve stability, which can occur when the next hop selected may have a weaker signal than an alternative node which is available. A feature known as Preferred Uplink and Auto Reselect is available in the latest access point firmware. That allows you to manually select the best path for a Wi-Fi mesh node to connect to the Wi-Fi mesh root. The wireless mesh node can then reselect another mesh node as the preferred uplink. It can also be used to deploy the mesh network topology according to a custom design. The preferred uplink option is available in the Mesh Setup menu, and here you can select the mesh node you wish to connect to. More details are available in Knowledge Base Article 7483 if you'd like to check it out. Okay, so to summarize, today we started with an introduction to wireless mesh networks. Here we looked at how it works and which model access points and routers support the mesh feature. We also looked at the different roles in a mesh network. Then we looked at the configuration steps to set up a mesh network, which included how mesh hops are calculated and a brief discussion on the mesh communication mechanism. We finished by looking at a couple of additional features, which were the Mesh Wired Uplink and the Preferred Uplink. Okay, that's all for now, but please stay tuned. We'll be answering questions in the live chat on the right of your screen for the next 5 minutes. For more information about Dratec products, please check out our website at www.dratec.com.au or send us an email to sales@dratec.com.au or give us a call on 02 9838 8899. Don't forget to like and subscribe below, and if you'd like a notification anytime we put up a new video, please give the bell a click too. Thanks and bye for now.